To the learning of computer networks and security. We are going to start with the module 5, that is multimedia networking. Already seen the concept of playout delay in Voip. So now let's move on to Voip recovery technique. How the recovery of packets can be made whenever the packet loss occurs. So that is what we have to see here. So what is the main challenge faced? It is something like whenever sender sends a packet, whenever sender sends an audio here, we are speaking about only audio. So this audio is actually broken up into multiple chunks. So those chunks will be carried over the network, and maybe when it reaches the receiver, some of the chunks or some of the portion of the audio might be lost in the network, and this loss might be because of network issues or maybe because of the congestion that has occurred in the network. And one portion of the audio, when it is lost, there should be some scheme here at the receiver, at the receiving end. There must be scheme here to recover from this packet loss. So that recovery should be in such a way that the received audio stream should be maximum, you can say tolerable to the receiver. So how it can be tolerable at the receiver end? So that loss should not be noticed here at the receiver end. So this received audio should be almost similar to the original transmission, where this lost packet should not be easily determined at the receiver side. So it is something like, you can call, we have a concept there in TCP to overcome such packet loss. So what is that mechanism in TCP? We have ACK mechanism, acknowledgement. So whenever a packet is lost in the network, when the sender is sending, say definitely our receiver will not send any acknowledgement, right? So whenever the acknowledgement is not received at the sender's end, so sender will start retransmitting the packet. Or suppose if when the sender is sending multiple packets, if any one packet is lost, there the receiver will notify the sender by sending duplicate acknowledgement. So through the acknowledgement, there was policy there in TCP, but here rather than using this ACK policy, what is the disadvantage of ACK here? It is time consuming. Several RTTs it requires. Maybe one RTT minimum is required to send the ACK, to receive the ACK at the sender side. So which is actually a delay here that is experienced at the receiver. So such a delay is not acceptable. So here alternate techniques we have in order to recover from packet loss in VoIP, and the first recovery technique is forward error correction. So what is the meaning of forward error correction here? So let's see this simple forward error technique. Okay, so the meaning of forward error is whenever a sender is sending an audio, the audio is sent in the form of, as I already said, in the form of chunks. And suppose here the sender itself introduces some mechanism when he is sending in such a way that that mechanism should help at the receiver end to recover from the packet loss. So what is the mechanism that the sender should use? See, whenever the sender is sending the original audio, what he can do is he can add one redundant chunk along with the original chunks. So what is this original chunk? So what is this redundant chunk here? So we will see that. So here sender is sending, rather than sending one chunk, sender is sending multiple group of chunks together, right? So suppose if I take that group of chunks as size as n, group size as n, and here since I'm sending 3 chunks together, let me take that group size is equal to 3. So along with those 3 chunks that the sender is sending, he will add one more fourth chunk, and that fourth chunk is nothing but the redundant chunk. Now how should be this redundant chunk? That redundant chunk should be repeated chunk. It should be helpful at the receiver end. Now suppose if any one of the packet is lost here out of these 3 original packet or original chunks, suppose here any one of them is lost, then the receiver should be able to recover that loss, recover that chunk through this redundant chunk. So this redundant chunk should be in such a way that the lost chunk can be recovered with the help of that. So here receiver will have a lot of advantage with this redundant chunk. So how should be this redundant chunk now? So chunk 1, you XOR simply all these chunks. So XOR the first chunk with the second chunk, and then again XOR it with the third chunk. So simply the XORed chunks is nothing but your redundant chunk here. So remember, in general, whenever you are saying it is the n plus 1 chunks that the sender is sending, and this n chunks is nothing but the group of chunks that the sender is sending, and that one chunk, extra chunk, is the redundant chunk, which is XOR of all these n chunks, and that using that extra redundant chunk, receiver will be able to recover from the packet loss. So you can say that this by doing this, you can increase the factor, increase the bandwidth. You can increase the bandwidth. That means the link capacity that you're using, that can be increased by 1 by n. So almost 33%. By 33% you can increase the efficiency by using this mechanism. And remember here the size of the group. So size of the group n here, it should be very much lesser. So here if the group size becomes larger, in that case what happens, that the receiver will have to wait for a long time to play that or to receive that group of chunks. So receiver is not receiving just one chunk at a time, he is receiving now group of chunks. Suppose if that group size is larger, in that case the receiver's play out delay will be increased. So since delay increases, definitely receiver will have to wait for long time. That is not acceptable. So here whenever the group size increases, what happens, the number of possibility of packet loss also increases, right? So suppose here in this mechanism what we have used, n plus 1, only one redundant chunk is added, right? So in this case actually if more than one packet is lost, in this example if more than one packet is lost, then using this one redundant chunk, it would be difficult for the receiver to recover from the packet loss. Remember, so if more than one packet gets lost in the network, suppose only one packet gets lost in the network, then easily it can be recovered. If more than one, that is 2 or 3 packets starts getting, if it gets discarded or lost in the network, then that becomes difficult to recover. We have already seen the first recovery mechanism. Now let's move on to the next recovery mechanism. You call that as forward error correction. So interleaving. So we have already seen the forward error correction technique. We have the second one, that is interleaving, but before that we have the second scheme in FEC, second scheme in forward error correction, and that scheme let's discuss here with the help of a diagram. So what was the first scheme used in forward error correction? Adding one redundant packet or chunk along with the group of n chunks. So the second scheme in FEC is the same error technique there, same recovery technique. So you can just see here. When the sender is sending the group of chunks, or you can call it as simply stream of chunks or stream of bytes. So let me call this as the chunk 1, chunk 2, chunk 3, and then chunk 4. So total 4 chunks here the sender is sending, and you call this as the original stream. And definitely when the sender is sending the audio in the form of chunks, that will be of high quality. so that the receiver will not experience any disturbance, or he will not the performance of the audio at the receiver end will not deteriorate here, right? It will not degrade here. So that's why sender will send high quality audio, right? So now definitely when the sender is sending, he will encode the audio, and that encoded audio should be of high quality when the sender is sending. Now suppose if the chunks are lost here in the network, how to recover from that? So definitely we will use the redundant techniques. So we will send along with this original stream redundant stream also. But how should be that redundant stream? You can just notice here in the diagram. So for every chunk here that is sent, original chunk, what we do is we will try to generate a low quality stream along with the original stream. So what is that low quality stream means? The encoding rate will be lesser compared to the encoding rate of the original stream. Suppose if the encoding rate of the original stream was 64 kilobits per second, our low quality encoded stream, low quality encoded redundant stream rate will be just say 13 kbps. So what is that? If you are encoding at a smaller rate, that becomes a low quality audio, and that low quality audio we are sending as a redundant stream. Why? Because this may take a small space, take up small space, and this redundant stream just acts as a backup, and only in the case of loss there, so which might get lost, the original stream high quality audio that you have sent, some of the chunks may get lost. So this is the solution. So how are you sending that low quality redundant stream? See how you're making it as redundant. You just check here. The first chunk is low quality chunk is created, that low quality encoded chunk is created for the first chunk, that is as it is. But when you're creating the second chunk, low quality chunk, you just append that low quality second chunk with the first chunk. So what do you do there? You just append the low quality second chunk with the first chunk or the previous chunk from the original stream. So you call this original stream as nominal stream. Actually you call this original stream as nominal stream. So you pick one chunk from the nominal, that is n minus 1. Let me call this as n minus 1. Why? Because here you are now constructing the nth redundant stream, nth low quality redundant stream. So when you're creating that, you have to pick one n minus 1 chunk from the original or the nominal stream and append that with the nth chunk here in the redundant stream. So what is this that you do here? N minus 1 is 1, that is chunk 1. You add it with the subsequent chunk 2. Same concept you have to use this for the third chunk also. Now whenever you are constructing this low quality third chunk, you have to append it with the previous chunk. So previous chunk from the nominal stream. So previous chunk of nominal stream, previous to 3 is 2, chunk 2. So append it with the nth chunk here in the redundant stream. Same thing applies here for the fourth chunk also. So everywhere the previous chunk from the nominal stream is added with the chunk, low quality chunk that you are sending. So this is how you are sending every time. Suppose here what happens when all these chunks are sent, somewhere in the network, say this third third chunk is lost. See here, you are sending the original stream 1 2 3 4, but how you are sending? You are appending that with the redundant low quality stream. So now this low quality stream is sent over the network. So whenever this low quality stream reaches at the receiver's end, say here this is third stream, third chunk gets lost, third chunk is lost. So which is reached first chunk is reached as it is, second chunk is reached which is added with the previous one also from the original nominal stream, but third is completely lost, but fourth you are getting, and fourth chunk, remember, is appended with the previous chunk, third chunk, which was taken from the nominal stream. Now tell me, at the receiver end, did I receive all the chunks here? Chunk 1 is received, yes. Chunk 2 is received, yes. Whether chunk 3 is received, not received, but you have received fourth chunk, but along with that you also have received third chunk, because already we had appended. So here 1 2 3 4, all 4 chunks where we are able to recover. But remember here, first chunk is original, second chunk is also original, fourth chunk is original, but this third chunk whatever you are getting is actually taken from the redundant. So here first, second, fourth are of high quality, but this third chunk is of low quality. So this low quality somewhere chunk is appended, inserted in between high quality chunk, but that is completely acceptable at the receiver's end. Why? Because it is better than the loss. What if this third chunk was totally invisible, totally lost there in the network? Definitely that portion of the audio what the sender had spoken is lost. So better than that is low quality encoded stream. So low quality chunk we have received. So here this type of recovery from packet loss mechanism is used in forward error correction. So we have seen two schemes in forward error correction. One was adding redundant n+1, one redundant chunk, but the second scheme is adding n-1 chunk from the nominal stream to the low quality encoded stream. So here the loss is recovered with the help of this low quality redundant stream. Next, we will see the second technique of recovery. So, first technique was forward error correction. Now, the second technique of Voip recovery is interleaving. Okay, so what is this interleaving concept? We will just see this with the help of an example. As you can see here, the sender sends an audio, but that audio is broken down into multiple chunks. You can see here. But how these chunks are taken? See, if a sender is sending an audio of 2 minutes, if a sender is sending an audio of 2 minutes, that 2 minutes audio is broken up into multiple chunks, wherein each chunk will be played for few seconds. Say the first chunk is played. See, the first chunk here is played for 20 milliseconds. First chunk is played for 20 milliseconds. So in each such chunk, you can see in each such chunk, you are dividing each such entire chunk into multiple units. So what did I do? That chunk 1 we have divided into 4 units. You can see how is it divided into 4 units based on time. The first unit is for 5 milliseconds, second unit is also for 5 milliseconds, third unit is also for 5 milliseconds, finally fourth unit is also for 5 milliseconds. So this entire chunk is played for 20 milliseconds. Remember, a chunk is divided into multiple units where every unit is played for is of duration, fixed duration, and that is 5 milliseconds. So this entire chunk is of duration 20 milliseconds. Now the second chunk is also again the same way of 20 milliseconds. This is also of 20 milliseconds. Next, fourth chunk is also of 20 milliseconds. Now, how are you going to send this original stream? So, using an interleaving technique. So, what is an interleaving technique there? You just notice the diagram. The interleaving technique here is the first unit of the chunk 1 is taken. Before sending, first unit of original stream is taken. The first unit again from the second chunk is taken. Again the first unit from the third chunk is taken. And again the first unit from the fourth chunk is taken. So finally I have taken unit 1 from chunk 1, unit 5 from chunk 2, unit 9 from chunk 3, and finally unit 13 from chunk 4. So all the very first units of 4 chunks are taken, and this is how one single redundant chunk is created. So you call this as interleaved. Next again you can see, continue. you're going to take the next chunk by considering the second unit from the first chunk, second unit from the second chunk, second unit from the third chunk, second unit from the fourth chunk. So all second units of every individual chunks are grouped together, and now second interleaved chunk is created. Okay, so second interleaved stream is created accordingly. So here these interleaved chunks you have noticed. Now suppose what if any one chunk is lost. See here, third chunk is lost. First chunk is received as it is, second chunk is also received as it is, no problem at all. But what happens when you receive when you don't receive this third chunk at the receiver's end? So definitely when the first chunk is received, he can't play as it is. Why? Because this contains the portion from multiple chunks, right? So before playing, you have to reshuffle this. You have to sort this. So how sorting can be done? Reshuffling can be done. You can just see here the chunk 1, chunk 2, chunk 3 is lost, but chunk 4 is received. So from all these 4 chunks, all these 3 received chunks, you try to regain the first chunk. So how should be the first chunk? Unit 1, unit 2, unit 3, and then unit 4 you should get. So from where are you getting the unit 1? So from the first chunk I'll get unit 1. Again unit 2 I'm getting from the second chunk, but unit 3 is missing. Instead unit 4 you are getting from the fourth chunk. So unit 3 you are not able to recover from any of these chunks. So total 3 units you have got. Similarly now the second chunk also you can reassemble by collecting. So 5 is there, 6 is there, and then 7 is not there, but 8 is there. So one portion is missing in this chunk. Similarly you can reconstruct all the chunks, but remember in all of these received chunks one portion is missing. Rather than missing the entire chunk, only one single unit in every chunk is lost, which is acceptable at the receiver's end. Okay, rather than losing the entire portion of the audio, only one small minute portion in each received chunk, each received audio, one small minute portion is missing, which is easily recoverable, or you can say it is acceptable at the receiver's end, tolerable at the receiver's end. So this is the interleaving technique what we have. So we have seen 2 recovery mechanism. One is forward error correction and one more is interleaving. Now we have the last one recovery technique called error concealment. The last scheme of packet recovery is concealing. So error concealment. So what is error concealment? Let's see now. In this error concealment technique, actually we are trying to produce replacement that is similar to original. So what is the meaning of that? See, sender is sending audio in the form of multiple chunks, right? So suppose if any one of the chunk in between or multiple chunks are lost when it is received at the receiver side. Suppose if the receiver doesn't have any redundant information technique, suppose here if the receiver is not having any redundant technique to recover from the packet loss, what our receiver can do here is he can simply replace that lost chunk with some other similar packet. So it is something like sender is sending an audio in the form of multiple chunks, and on the way when it reaches the receiver, some chunks in between might be lost. So receiver will try to replace that lost chunk with some other chunks that is already received, other chunks which is already received and which is found to be similar. So this is applicable to audio with self similarity. Sometimes whenever we go with a conversation or something, some of the audio portion will be similar there, right? So some of the words may be similar, or some of the portions of the or the signals, or the maybe some of the words phonemes might be similar there, right? So there for such self similar audios this would be more applicable. So receiver can go with the strategy. What is it? So receiver can replace the lost packet. Suppose here the sender is sending 3 chunks as a form of one audio. So whenever the receiver receives, maybe the first chunk he is receiving, okay, and then second chunk he's not receiving because it is lost, and then what is receiving is third chunk. Okay, so first chunk is receiving, third chunk is receiving, but missing is second chunk. So here receiver can replace or recover that loss by simply replacing the second lost chunk with the immediately or with the chunk that was received immediately before the loss. So what was the chunk received immediately before the loss? That was first chunk, right? So the second chunk is simply replaced by again with the first chunk that was received earlier. So what you can do, a gap is filled here. So receiver has got now 3 chunks, where the second chunk is actually not the original one, but it is simply the replacement by the first chunk itself. This is simply a repetition there. So somewhere it might be similar, right? So that is how the receiver is trying to recover. So it is something like filling something is better than not having anything here. So rather than having a gap, you just replace that with the previous one. So you can also go with some other strategy like replacing this gap or missing chunk with the next chunk that you're receiving, right? So that also can be done. So such recovery techniques is followed in VoIP. So we have an example. Example is actually Skype. So already we have this Skype as a example. So you can just go through this Skype. You can take it as a case study in order to analyze the Skype, which is actually implementing this VoIP technique, and you have also error or packet loss technique, which is implemented in Skype. So I hope you all can learn this Skype, that is peer-to-peer communication or video conversation happening between multiple clients in Skype using VoIP.